Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera kepada semua pelajar Kolej Matrikulasi Pahang yang disayangi. Saya Puan Yuniza binti Muhammad sebagai moderator bagi program CHEMScore pada hari ini. Di mana CHEMScore adalah program anjuran unit kimia di bawah kelolaan Jawatan Kuasa Kecemerlangan Akademik Pelajar, ya, di mana program ini dilaksanakan bagi membantu pelajar-pelajar menguasai topik yang telah dipelajari dalam kursus kimia pada semester 2 ini. Bersama saya pada hari ini ialah Puan Rabiah binti Abdullah sebagai penceramah dan dibantu oleh Puan Nur Wahyuni binti Nazri dan Encik Muhammad Nur Hisham bin Ahmad. Sebelum saya meneruskan program pada hari ini, eloklah saya memperkenalkan dahulu penceramah kita pada hari ini. Puan Rabiah merupakan pensyarah kimia Kolej Matrikulasi Pahang dan telah berkhidmat selama 13 tahun. Dan beliau mempunyai kelulusan ijazah sarjana muda dengan pendidikan kimia dan matematik dari Universiti Malaya. Sebelum ini beliau juga telah berkhidmat sebagai pensyarah kimia di Kolej Matrikulasi Johor. Baiklah, seterusnya saya akan serahkan kepada Puan Rabiah untuk meneruskan program CHEMScore pada hari ini, di mana Puan Rabiah akan membincangkan topiknya bagi chapter 1, chapter 2 dan chapter 3, iaitu tajuk reaction kinetic, Thermochemistry dan Electrochemistry. Jadi suka saya ingatkan kepada para pelajar, sekiranya terdapat sebarang pertanyaan, pelajar boleh menulis di bahagian ruangan chat, ya, pada akhir program ini nanti. Baiklah, tanpa membuang masa, saya akan serahkan kepada Puan Rabiah. Silakan.
Okay, so start.
Okay.
Huh?
Show.
Show.
Tik
Oh, sekejap.
Tak boleh.
Tak boleh, tak boleh
Oh,
tik.
dah.
Boleh. Okay.
Cancel sekejap. Sekejap. Share screen. Okay.
Tak, kalau ditutup speaker dengar. Cuma yang
Assalamualaikum. Welcome to CHEMScore SK025. I'm Madam Rabiah binti Abdullah. We'll discuss about physical chemistry chapter 1, 2 and 3. This is our format for PSPM. The marks allocated for reaction kinetic is 10.4, thermochemistry 10.4, electrochemistry 7.0, organic chemistry 52.2. So the total marks allocated is 80. So percent for PSPM is 40%. Percent for PB is 60%. So the total is 100%. Let's look at chapter 1, reaction kinetics, that consists of rate of reaction, collision theory and factors affecting reaction rate. Order of reaction is zero order, first order and second order reaction. The rate law for zero order is rate equals to K concentration of A to the power of 0. For the first order, rate equals to K concentration of A to the power of 1. And for the second order, rate equals to K concentration of A to the power of 2. The unit of rate constant for zero order is ms -1, first order s -1, and for the second order is m -1, s -1. The graph of rate versus concentration for the zero order is a flat graph. It means that the concentration of the zero order is independent to the rate of reaction. It means that if you increase the concentration of reactant, the rate of reaction will not affect. For the first order reaction, since that rate is equals to K to the power of 1, so we have a straight line graph. So the concentration of reactant will increase as the rate of reaction will increase. Okay. So if you double the concentration, so the rate will be double. For the second order reaction, since that the rate of reaction is Ka to the power of 2, so we have these types of graph, which is a quadratic graph. Okay. So the graph is if you increase the concentration, or double the concentration, the rate of reaction will increase by a factor of 4. The integrated rate law for each order of reaction need to be memorized. So the integrated rate law for zero order is A naught minus A equals to KT. For the first order is ln A naught over A equals to KT. Second order is 1 over A minus 1 over A naught equals to KT. So the linear graph for zero order and first order have a negative slope graph, and for the second order is a positive slope graph with 1 over A naught as intersection of y. The half-life for the zero order is A naught over 2k, first order is ln 2 over k, and second order is 1 over k A naught. The graph of half-life is always be concentration of A versus T. If you plot the graph of concentration A versus T and you get a straight line graph with a negative slope, confirm the order of reaction is zero order. And if you plot the graph of concentration of A versus T and you get these types of graph, which is a curve graph like this and like this, so it must be first or second order. So how to differentiate the curve graph of first order and second order is, okay, let's look at the definition of the half-life. Definition of half-life is half of the initial concentration. So let's say the initial concentration here is 1.0. So the half of initial concentration is divide by 2. Let's say 0.5. Okay, so we get here. And half for the second half-life is 0.5 divided by 2. So we get 0.25, or the initial concentration divided by 4. So we get these types of x. So as we know that here x and x, the first x here is the first half-life. The second x here is the second half-life. If the value of the first half-life is the same as the second half-life, confirm it is a first order reaction. For the second order pula, okay, so this is the initial concentration, which is 1.0. So the half-life is 0.5 divided by 2. So we get the value of T here. And for the second half-life, 0.5 divided by 2, or 0, the initial one divided by 4. So we have 0.25 and we get here. So the value of the first half-life is x and the second half-life is 2x. It means that the second half-life is double the first half-life. So confirm it is a second order reaction. Look at the question from PSPM 2020-2021. Decomposition of gaseous hydrogen iodide at 508 degrees Celsius is represented by the following equation. The molar concentration of Hi was measured at time interval in seconds, and the graph of concentration against time for the decomposition of Hi at 508 degrees Celsius is shown in figure 1. Based on figure 1, determine the order of reaction and write rate equation for the decomposition. So this is the graph of concentration versus T, and we have a curve graph. So concentration versus T is a half-life graph. So since that we have a curve graph, it may be first order or second order. So we need to determine the first half-life and the second half-life. So here is the initial concentration, which is 0.1. So the first half-life is 0.1 divided by 2. So we have 0.05 here, and we get 125 second here, 125 second. And the second half-life is 0.05 divided by 2. So we have 0.025, and we have here. So here is 375. Okay. So here is 125. So here is 375 minus is 125. So we get 250. Okay. So it means that the first half-life is not the same as the second half-life. So it may not be first order reaction. But the second half-life here is double the first half-life. So that's why we have a second order reaction. So the rate of reaction is rate equals to K concentration of Hi to the power of 2, since that it is a second order reaction. For the question A2 is calculate the rate constant K and initial rate for the decomposition of Hi. So to find the rate constant, as we know that the formula for the half-life for the second order is 1 over K concentration of A naught. So we just substitute the initial concentration 0.1 here, and we get 0.08. So the unit for the second order is M-1 S -1. So we just come out with the formula of rate law. Rate equals to K concentration of Hi to the power of 2. So K here, we get from here 0.08. The concentration of Hi at initial 1 is 0.1 to the power of 2. And we get this answer. There is 5 factors affecting reaction rate, which is temperature. Increasing the temperature, particle move faster, more effective collision, and higher rate of reaction. Concentration. Higher the concentration, more particles per unit volume, more particles to collide and react, more effective collision, and of course, higher rate of reaction. For the pressure, pressure increase number of particles per unit volume, increase the frequency of collision, and rate of reaction increase. Surface area, the smaller the pieces, the larger the total surface area. There is an increased area for the reactant to collide with, more effective collision, and higher the rate of reaction. And the last factor is catalyst. Catalyst speed up the reaction by lowering activation energy. More particles reach EA, so that higher rate of reaction. The Arrhenius equation is K equals to AE to the power of EA over RT, and the derivation of this Arrhenius equation is ln K equals to negative EA over R plus ln A. And this simplified Arrhenius equation will be applied in graph. The last Arrhenius equation, which is ln K1 over K2 equals to EA over R 1 over T2 minus 1 over T1. And this formula of Arrhenius equation will be applied when the question given have two different T. Let's discuss the question of PSPM 2019-2020. The activation energy for the above reaction using a tungsten catalyst is 163 kJ per mole. How many times faster is the reaction if the temperature is increased from 450 to 550 degrees Celsius? So now we have two different T here. So we can apply the third Arrhenius equation, which is ln K1 over K2 equals to EA over R 1 over T2 minus 1 over T1. Remember that the EA value here is in kilojoule per mole, and the R value here is 8.314 in joule. So we have to convert the EA value into joule, which is times 10 to the power of 3 joule. Okay, so just substitute the value. So since that the T here is in degrees Celsius, we need to convert into Kelvin plus 273.15. So we have this and this. So we just substitute the value and calculate. So we get the ratio of K1 over K2 is 26.9, which is approach to 27. So that the reaction at 550 is 27 times faster than 450 degrees Celsius. Chapter 2, Thermochemistry. We have concept of enthalpy, calorimeter, Hess law, and Born-Haber cycle. The basic principle in calorimeter is heat released by reaction or hot substance equals to heat absorbed by surroundings. The surrounding here refer to water and calorimeter, or solution and calorimeter, or calorimeter, or water, or solution. There is several situation in calorimeter. The first and second situation is involving bomb calorimeter or constant volume calorimeter. This bomb calorimeter normally involving combustion reaction. So heat released from the reaction of combustion equals to heat absorbed by water and calorimeter if the bomb calorimeter consists of water. Okay, so the formula will be Q equals to MC delta T plus MC delta T, or Q equals to MC delta T plus C delta T. So W here is referred to heat absorbed by the water, and the C here is referred to heat absorbed by the calorimeter. The difference between the first formula and the second formula is the first formula is MC delta T, which refers to the small c here, which is a specific heat capacity of calorimeter. Okay, and the second formula is C delta T. It means that the capital C here refer to heat capacity of the calorimeter. So it depends on the questions given, whether the questions give the information of specific heat capacity or heat capacity. Okay, the second is heat released from reaction equals to heat absorbed by the calorimeter. Okay, this one is used for the bomb calorimeter that have no water. Okay, so it means that heat released from the combustion reaction will be absorbed by the calorimeter only. Okay, water here does not included. So the formula is Q equals to MC delta T or C delta T. The third situation is neutralization reaction in coffee cup calorimeter. So here heat released from the reaction equals to heat absorbed by the solution and calorimeter. So the formula is MC delta T plus MC delta T, or MC delta T plus C delta T. So the S here refer to heat absorbed by the solution, and C here refer to the heat absorbed by the calorimeter. So the difference is depends on the question whether given is specific heat capacity of calorimeter or heat capacity of calorimeter. The fourth situation is heating the water, where heat released from the combustion of gas equals to heat absorbed by the water. So the formula is Q equals to MC delta T, which is W is referred to heat absorbed by the water. The fifth situation is putting hot metal in water, where heat released from the hot substance equals to heat absorbed by the water. So the formula will be MC delta T equals to MC delta T, or C delta T equals to MC delta T. So the difference between the first one and the second one here is depends on the question, whether the question given is specific heat capacity of the hot substance or heat capacity of the hot substance. So H here refer to the hot substance and W here refer to the heat absorbed by the water. The sixth situation is making lukewarm water, where heat released from hot water equals to heat absorbed by the cool water. So the formula will be mc delta T equals to mc delta T. So the first here refer to the heat released from hot water, and the second, the two here refer to the heat absorbed by the cool water. Let's look at the question from PSPM 2019-2020. The question is, ethanol is produced from fermentation of sugar canes and widely used as an alternative fuel to replace petrol. A 1 gram sample of ethanol was burned in a bomb calorimeter. So it means that these questions involving the first or second situation in notes that we have already discussed before, which has total heat capacity of 11 kilojoule per degree Celsius. The temperature of the calorimeter and its contents increase from 25 to 27.7 degrees Celsius. So let's carry out all the information given. So the information is the mass of ethanol. So mass of ethanol, CH3CH2OH equals to 1.0 grams. Then the total heat capacity. So heat capacity here refer to the capital C of calorimeter. So it is 11.0 kilojoule per degree Celsius. And the temperature of the calorimeter contents increase from 25 to 27. So we need to find the delta T, which is 27.7 minus 25. We get 2.7 degrees Celsius. So let's look at the first equation. Write a balanced chemical equation for the reaction that takes place in a bomb calorimeter. So as we know that this is a combustion reaction. So combustion involving oxygen gas. So this ethanol react with oxygen. As we know that all organic compound that undergoes combustion will produce carbon dioxide and water. So we just balance this equation. The second question is, calculate the enthalpy of combustion of ethanol per mole. So per mole here refer to per 1 mole. So first we need to calculate the moles of ethanol. So the mass given, okay, so we need to divide with the molar mass. So 1 divide the molar mass, which is 46. So we get 0.02174 mole. So heat released by the combustion here will absorbed by the calorimeter or calorimeter and water. So from the questions here, we know that the was burned in a bomb calorimeter. So does not mention about the calorimeter. The bomb calorimeter consists of water, and also the information given does not mention about any mass of water. So we know that this bomb calorimeter does not consisting of water. So we know that heat released by the combustion of ethanol will absorb by the calorimeter only. So the formula will be mc delta T or C delta T. So since that the information given is heat capacity, so we use the formula of C delta T. So the C here given is 11. The delta T is 2.7. We just substitute the formula, the values into formula. Then we get negative 29.7 kilojoule. So the delta H here need to divide with the number of mole. So we get negative 1366 kilojoule per mole. Why negative? Because this is a combustion. Combustion is heat release. So heat release is exothermic reaction, which is negative value. Let's continue about Born-Haber cycle or energy cycle diagrams. So before you construct these energy cycle diagrams, you need to memorize all the definition of enthalpy involved. So you need to follow several steps to construct or to complete this energy cycle diagram. Step 1 is enthalpy of formation. Step 2, enthalpy of sublimation or atomization. Step 3, first ionization energy. Step 4, enthalpy of atomization. Step 5, electron affinity. And step 6, lattice energy. Now we discuss the question from PSPM 2018-2019. The question is, thermochemical data for the formation of sodium oxide is given in table 2. Construct a Born-Haber cycle for oxide and calculate the enthalpy of atomization of sodium. So before we construct the Born-Haber cycle, we need to come out the equation first for each enthalpy. So here is ionization energy of sodium. So the ionization energy is minimum energy required to remove 1 mole electron from 1 mole of gaseous atom. So sodium gaseous atom remove 1 mole electron and it becomes a positive charge ion. Enthalpy of formation of sodium oxide. So formation 1 mole of compound. So the compound is sodium oxide solid formed from its element. So the element is solid plus with the oxygen gas. This one must be 1 mole. So this becomes half of oxygen gas. First electron affinity of oxygen. Electron affinity is heat change when 1 mole of gaseous atom gain 1 mole of electron. So oxygen gas gain 1 mole electron and it becomes a negative charge ion. Second electron affinity, O minus gas gain electron and it becomes O2 minus gas. Enthalpy of atomization of oxygen. So 1 mole of gaseous atom is formed from its element. So element half. Lattice energy of sodium oxide is 1 mole of compound. So Na2O solid is formed from its gaseous ion. So Na plus gas plus O2 minus gas. So this becomes 2 mole. So the question asks to calculate the enthalpy of atomization of sodium. So we need to add the delta H atomization of sodium, which is the equation is 1 mole of gaseous atom is formed from its element. So this one is delta H need to be calculated. Okay, so then we need to construct a Born-Haber cycle after this. Here I'm just copied from the previous slide. So first we need to identify which enthalpy we need to write first. So we just focus on the enthalpy of formation first. The second one is the atomization of sodium. Okay, the third one is IE for Na. The fourth one is atomization of oxygen. The fifth one is the first Ea, second Ea, and the last one is lattice energy. So we write the enthalpy of formation here, which is 2Na solid plus half of oxygen gas produce Na2O solid. So this one is solid. So the value is negative 414 kilojoule. Okay, settle for the first one. For the second one is atomization of Na. So Na here, Na solid to Na gas. Na solid to Na gas. But this one is 2 mole of Na solid. So we need to balance the equation. So it becomes 2 Na gas. So this one is delta H. Delta H here referred to 1 mole. So since that this one is 2, 2. So this one we need to write 2 delta H. Okay. Next, the third one is ionization energy. So this one is 2Na. So since that 2Na here, so we produce 2Na plus. So 2Na gas produce 2Na plus gas. And also this one also need to multiply by 2. So here is 6 times 2. Okay. So settle for the atomization. Then we focus on the oxygen. So oxygen, The fourth one is this one, half oxygen produce O gas. Okay, this one is positive 249. The fifth one is the first EA. So O gas to O minus gas. So for oxygen gas, no need to multiply by 2. Okay. So O minus gas, the value is negative 141. And the second one, second EA, O minus to O2 minus gas. And this one is positive 750. Okay, so this one becomes lattice energy. So the values for lattice energy is negative 2478. Okay, so the delta H formation equals to the total up of this. So the delta H formation is negative 414 equals to 2 delta H plus 496 times 2 plus 249 plus negative 141 plus 750 and plus negative 2478. So the 2 delta H here is equals to 214. So we need to find the delta H. 214 divided by 2 equals to positive 107. Why positive? Because this is atomization, heat absorbed, okay, in kilojoule per mole. Chapter 3, Electrochemistry. We have galvanic cell, Nernst equation, and electrolytic cell. Here is the difference between galvanic cell and electrolytic cell. In galvanic cell, the anode is in negative charge, where it is the source of electrons, but cathode is a positive charge, where it accepts the electrons. So in galvanic cell, the electron flow from anode to cathode. In electrolytic cell, the anode is a positive charge according to the battery, and the cathode is a negative charge. In galvanic cell, the electrolyte separate by two beakers here. And the electrolytic cell, electrolyte is only in one beaker. In galvanic cell, there is a salt bridge. Okay. And in electrolytic cell, there is no salt bridge. In galvanic cell, we use voltmeter. And in electrolytic cell, we have a battery. Okay, both has anode and cathode for galvanic cell and electrolytic cell, where at anode for galvanic or electrolytic cell, both undergoes oxidation reaction, and at cathodes, both galvanic and electrolytic cell undergoes reduction reaction. And both galvanic cell and electrolytic cell flow the electrons from anode to cathode. There is 4 types of question that we'll ask in final exam involving galvanic cell. So the question may start with cell notation, standard electrode potential value, overall equation, or in diagrams. So whatever it is, you need to determine the anode and cathode first. So if the question gives the cell notation, the anode will be at our left side. So here is the anode. And our right side here is cathode. Okay. So the anode, the half equation for anode here is hydrogen produce H plus aqueous. So we need to balance the equation. So becomes 2 here plus 2 electron. Okay. And at cathode here is Au3 plus aqueous accept 3 electrons and becomes Au solid. So as you can see here, the anode increase in oxidation number from 0 to positive 2, and the cathode is undergoes reduction because the oxidation number reduced from positive 3 to 0. Okay, the second one is standard electrode potential. So here is standard potential value. This one belongs to the Ag plus Ag, and this one belongs to Pb2 plus Pb. Okay, so from the value given, we can identify the anode and cathode, which is more positive value will undergoes at cathode, and more negative value is anode. Okay, so here the half equation at anode belongs to PB. Okay, whether PB2 plus or PB, we start with the PB since that at anode the oxidation undergoes oxidation. So PB solid produce PB2 plus equals plus 2 electron. At cathode, the Ag plus equals plus electron produce Ag solid. So this one, you can see that the oxidation number at anode increase from 0 to positive 2, and at cathode, the oxidation number decrease from positive 1 to 0. Okay, if the question gives the overall equation, you need to find the pair first. So here, Ce4 plus is paired with Ce3 plus, and CO here is pairing with the CO2 plus. So Ce4 plus to Ce3 plus, the oxidation number is reduced from positive 4 to 3 plus. So this means that this is undergoes reduction that occur at cathode. And CO here from 0 to positive 2. So this one undergoes oxidation that will occur at anode. So the half equation at anode is CO solid produce CO2 plus aqueous plus 2 electron, and half equation at cathode is Ce4 plus aqueous plus 2 electron produce Ce4 plus Ce4 plus 3 plus 1 electron produce Ce3 plus aqueous. Okay, if the question gives the diagrams, you can see the flow of electrons. So you can see that now the electron flow from anode to cathode. So here, okay, so the arrow is from left to right. So of course, our left here is our anode and our right here is the cathode. So we can write the half equation, which is at anode is Fe solid to Fe solid to Fe2 plus aqueous plus 2 electron. At cathode, okay, this one is Cd, so Cd2 plus aqueous plus 2 electrons becomes Cd solid. Next is determination of E naught cell and E cell. So what is the difference between these two is E naught cell here refers to the standard condition. What is the standard condition? The temperature is 0 degrees Celsius. The pressure is 1 atm. So the formula is E naught cell equals to E naught cathode minus E naught anode. But for E cell here is for any temperature and pressure. We call that as a nurse equation. So the formula is E naught cell minus 0.0592 over N log concentration of product over concentration of reactant. Let's look at the question from PSPM 2018-2019. The question is, a galvanic cell is constructed based on the notation below. The cell potential is 1.58 volt when the concentration of Zinc2 plus and Ag plus are X molar and 0.15 molar respectively. Calculate the value of X given E naught cell equals to positive 1.56. So as we discussed before, if the equation given is the cell notation, so we need to identify the anode and cathode. So of course, our left side here is the anode and our right side here is cathode. So the anode will be zinc that produce Zinc2 plus and cathode is Ag plus that produce Ag. So we get the cell reaction or overall equation here is zinc plus 2 Ag plus produce Zinc2 plus 2 Ag solid. So since that the equation given is X molar concentration, so it means that the concentration of reactant and the product. So we need to come up with the formula of Nernst equation, which is E cell equals to E naught cell minus 0.0592 over N log concentration of product over reactant. So here the E cell given is 1.58 and the E naught cell given also, which is 1.56. So minus 0.0592 over 2. 2 here refer to the number of electron. So 2 and 2. Okay. Log concentration of product from the overall equation, which is zinc, and the concentration of reactant is Ag plus to the power of 2 because of 2 mole here. Okay. So we just substitute the value into the formulas. Then you can find the values of X, which is equals to the concentration of zinc, which is 4.75 times 10 to the power of negative 3 here. Okay, should be negative 3 molar. There is 4 steps in applying Faraday's law. The first step is calculate Q equals to IT, where Q is electric charge in coulomb, I is current in amperes, T is time in second. Step 2 is find Faraday's constant, where 1 Faraday equals to 96500 coulombs, or 1 Faraday equals to 1 mole of electron. Step 3, write half equation at anode or cathode. Step 4, calculate number of moles from equation. And the last step, which is step 5, is calculate mass or volume of products. Let's look at the question from PSPM 2018-2019. The question is a charge of 0.025 Faraday was passed through an aqueous solution of Mn plus using a current of 2 ampere. An amount of 0.79 grams of M was deposited at the cathode. Given molar mass of M is 63.2 gram per mole. Calculate the time taken in minutes for the deposition of M. So we start with the step 1, Q equals to IT. So here the information given only I, which is 2 ampere. But we need to find the time taken T, and the Q coulomb does not be given. So we cannot start with step 1. So we move to step 2. 1 Faraday equals to 96500 coulombs. So since that the question give is 0.025 Faraday, so we may start with step 2, which is 1 Faraday, 96500 coulomb. So if 0.025 Faraday, so we can find that the coulomb is 2412.5 coulomb. Then we move to step 1, Q equals to IT. So we find the T value. So the Q here is from the first, the step 2, divide by 2 ampere. So we get 1206.25 seconds. But the question is need to calculate the time taken in minutes. So we need to convert the second into minutes by dividing with the 60. So we get 20 minutes. For the question, second question is calculate the volume of oxygen gas liberated at the anode at STP. Okay, so here we doesn't give the question doesn't give the value of I and T, so we cannot start with the step 1, step 2 also. So we need to start with the step 3, which is write the equation. So an anode that produce oxygen must be from water. Okay, so this is the equation. So step 4 is from the equation we know that this is 4 electron. Okay, 1 electron is equal to 1 Faraday. So 4 electron is 4 Faraday. So 4 Faraday is equivalent to the 1 mole of oxygen. Okay, so if we have 0.025 Faraday, so 0.025 Faraday, so times 1 divided by 4, we have 6.25 times 10 to the negative 3 mole of oxygen. So step 5, the volume of oxygen is the number of mole times with the STP here. We need to multiply with the 22.4. Then we get 0.14 dm3. That's all. Thank you everyone. Good luck for your final PSPM. Bye.
Okay, Assalamualaikum. Terima kasih kepada semua student yang telah join YouTube live pada petang ni. Sebarang pertanyaan boleh ditanya melalui chat box di ruangan chat. Okay. So saya ingatkan bahawa minggu ini adalah week 11. So kita ada lebih kurang dalam 7 minggu lagi untuk PSPM. So this is our macam nak membantu student lah untuk PSPM nanti. Okay. So hope this sharing will help you to for revision for PSPM. Okay. So this only chapter 1, 2 and 3. So another YouTube live will be in organic. Okay. Will be sharing by other lecturers lah. Okay, that's all for me. Thank you.
Baik, terima kasih diucapkan kepada Puan Rabiah atas perkongsian ya bagi 3 chapter tadi. Diharap ya. Jadi kalau saya lihat pada bahagian ruangan chat ni, pelajar tak ada pun yang bertanyakan apa-apa soalan ya mengenai topik yang dibincangkan tadi. Kemungkinan saya sempat berbincang dengan Puan Rabiah tadi, kemungkinan ada pelajar-pelajar yang belum membuat ulang kaji ya kepada 3 topik ni. Jadi tak apa, saya kira ini adalah inisiatif ya pensyarah unit kimia di mana unit menjalankan ulang kaji ni pada ya awal dikira awal lagi lah ni ya untuk membantu pelajar-pelajar mengulang kaji dan menguasai topik ini. Jadi pelajar boleh gunakan video YouTube ni nanti ya di mana video ni akan berada dalam channel unit kimia di mana pelajar boleh lihat berulang-ulang kali ya untuk membantu ya pelajar-pelajar membuat ulang kaji nanti. Okey, jadi untuk mendapatkan bahan yang digunakan oleh Puan Rabiah tadi, yang dibentangkan oleh Puan Rabiah tadi, saya akan kongsikan ya soft copy slide yang Puan Rabiah guna tadi dalam Telegram ya, kumpulan Telegram pelajar, dan juga saya akan bagi kepada semua pelajar tutoran melalui kumpulan Telegram atau ya kumpulan WhatsApp grupnya. Okey. Jadi jangan risau, pelajar-pelajar boleh mendapatkan soft copy ya pembentangan daripada Puan Rabiah tadi. Okey. Jadi saya kira kalau lihat di sini tak ada apa-apa pertanyaan. Jadi setakat ini saja kita punya program pada petang ini, dan pada minggu hadapan dan seterusnya akan diadakan lagi ulang kaji seperti ini ya. Jadi pelajar-pelajar jangan lepaskan peluang ini, dan diharapnya program yang kita laksanakan pada hari ini dapat membantu pelajar-pelajar untuk membuat ulang kaji, menguasai topik 1, 2 dan 3 dan seterusnya dapat meningkat. Terima kasih kepada rakan-rakan saya iaitu Encik Muhammad Nur Hisham sebagai JK Teknikal dan Puan Nur Wahyuni sebagai pensyarah yang membantu ya untuk menjawab soalan.